Well, hello. In this video, we're going to be looking at the beginning of Chapter 1. And as you can see here, we're looking at, in this chapter, we're going to be looking at exploring data. More specifically, we're going to be looking at a lot of the distribution of data and how to make decisions based on whatever that data might be. Whether you realize it or not, you already are in the habit of doing that. If you are shopping on Amazon.com and make a decision based on some of the reviews that people have made, you're looking at statistics and making a decision based on those statistics. If you are making a decision on what you're going to do for the day based on the temperature and what the prediction for the temperature is going to be for that particular day, you're using statistics. If you are in fantasy football, obviously there you're looking at a lot of statistics and using those statistics to base decisions on who you're going to draft. So you're already familiar with that. So in this chapter, we're going to be exploring that even further. For example, let's take a minute and look at this graph here and see what kind of decisions we can make based on this graph. So as we look at this graph, there's some things that we can notice. For one, we can see down at the bottom, we can see that there's a source here, so we know that this is true data. It's from 2008, dealing with and you can see from the title of the graph that it's unintentional injury deaths by age and event in the United States for the year 2004. So as you look at this data, we can also see that they have a key down at the bottom, and not only do they have different colors, but to help, they put symbols along the lines just to help distinguish between the different colors. And let's say if we're looking at trying to prevent deaths at different ages, we can look at this data and let's look at the red line there. That's the highest. There's the most deaths there. And if you look, that's dealing with motor vehicle deaths. So you can see that people around their 20s, between 18 and 22, somewhere in there, or 25, that's where the most deaths are occurring. And so that would be a big place to hit on, is focusing on that age group and motor vehicle safety. As people get older, you can see that that starts to decline. And in between the ages of 40 and 50, the most deaths there are dealing with poisoning. And as you look even further, as people get older, there's less and less poisoning, there's less and less driving deaths, because maybe as people get older, they're driving a lot less. But even with the blue line there, you can see that falls are the most common cause of death as people get older, which makes sense. So that's how we can look at data and evaluate data and maybe make decisions based on that data. So in this particular chapter, or lesson I should say, we're going to be focusing on looking at variables, tables, and graphs. But before we do that, there's some terms to be familiar with. We already talked a little about statistics, but statistics itself is a science of the collection, organization, analysis, and interpretation of data. Or you could also look at a statistic as being a number used to describe a set of numbers. For example, a median, mean, standard deviation. Those are all things that we're going to be looking at. Now in this particular section, it's going to be important to know these three specific terms. A variable is a characteristic of a person or thing that can be classified, counted, ordered, or measured. Those would be things like a person's gender, their height, their age, their weight. Those are all things that would be measurable. A population then is the set of all individuals or objects that you want to study. And the key there is that it is all of the individual or objects. And then a subset is just a subset, or a sample I should say, is just a subset of the population. So for example, if you want to make a decision based on all sophomores in Edina, you might look at, so that would be the population, would be all the sophomores in Edina. The sample would be, you're not going to maybe have an opportunity to interview every single sophomore, because maybe there's students that are sophomores that live in Edina that go to other schools other than Edina High School. So maybe the sample is just the ones that you're interviewing for whatever your survey is. So let's look at an example here. This is one where it says a medical laboratory technician draws 10 milliliters of blood in order to determine the number of white blood cells in a patient's bloodstream. We want to identify what the variable, population, and sample are. Now, sometimes it's easier to focus on the smallest part, the sample, and kind of grow from there, because a sample is going to be the more specific piece of information. So we're specifically looking at 10 milliliters of a person's blood sample. So that would be what the sample is. 10 milliliters of blood. Now the population in this case is going to be all of it. Well, obviously a person has more than 10 milliliters of blood pumping through their body. So the population in this case would be all of the patient's blood. And the variable is the piece that we are trying to measure. And we're measuring here the number of white blood cells. So that would be the variable, because that is the piece that is being measured. Let's look at another example. Here it says in Boston, 2,145 selected inline skaters were chosen for a survey and asked to classify their ability as beginner, average, or advanced. They were also asked whether they wore protective gear like helmets, knee pads, shin pads, and elbow pads when skating. The data were organized in a table like the one shown here. So you want to figure out, is the data based on a sample or the entire population? And it's clear that it's looking at a sample. The reason why we know it's looking at a sample is because it's dealing with selected inline skaters. It's not looking at all of the inline skaters in Boston. It's only looking at selected ones. So this would be a sample. And it says what variables are presented. Well, we have the first variable would be dealing with their skill level. Now, the no gear, the 1 piece, the 2 to 4 pieces, and the total, those are individual parts that are all dealing with and describing the amount of protective gear worn. So that would be your other variable. And then it asks, what percent of skaters wore no gear? What percent of skaters wore no gear? Okay, well there's a total of 2,145. We need to remember that when we're finding a percent, it's always the part that we're looking for over the whole amount. So this is dealing with all skaters, and what percent of all skaters wore no gear? So there were 874 skaters that didn't wear any gear. So we're going to figure this out by taking 874 and divide that by our total, 2,145. And when you do that, we get a decimal of 0.407, which when we convert that to a percent is approximately 40.7%, or we could say round it to 41%. Then it says what percent of beginners wore no gear? Well, now we're looking at, they ask us to find and focus on just the beginners that wore no gear. Well, there's a total of 709 beginners, and out of those 709 beginners, 188 of them did not wear any gear. So again, it's always the part divided by the whole. So for this one, we're going to take our part, which is 188, and divide that by the whole amount, which is 709. And when you do that, we get approximately 0.265, which will change to a percent, which would be 26.5%. Then it says how many skaters said they were advanced. Well, that's not looking for percent, so you got to be careful. They're just saying how many skaters said they were advanced. So when we look at the advanced skaters, there's 754 of them. And how many advanced skaters wore no gear? So now again, we're focusing on this row of numbers. So out of those advanced skaters, how many of them wore no gear? Well, there were, oh, I'm sorry, wore gear. I misread that. How many advanced skaters wore gear? Well, that's referring to these two numbers. And if we add those two together, 242 plus 140, we get a total of 382 skaters that wore some type of gear. Let's look at some other pieces of information. Now, there are different types of variables. There's two different types of variables that are important to know about. There's what's called a categorical variable. These are variables that don't correspond to specific numbers. These would be things like if you're asking a person what their favorite color is. Okay, that's not referring to specific numbers. If you're asking them what sex they are or what religion they would consider themselves. Those are all things that are not corresponding to specific numbers. And then we have a numerical variable. Well, that makes sense that that would refer to values where numerical values can be calculated. So things like where we could find the average and the mean from the set of numbers. And there's something that we want to do. There's three things that we want to do whenever we look at a table. We want to first ask ourselves what variables are presented. Is the data trustworthy? And that the way that you can figure out if it's trustworthy is by looking at whether or not there's a source that has been cited, and what conclusions can you get from the data. And sometimes the tables that we're going to look at are going to be rather large. Let's look at this one. So here we can look and see that yes, there is a source that's cited. This is from the Census Bureau. It's talking about the highest level of education completed by household, and then it looks and compares that, or looks at the percent distribution by income level. So we're comparing the income level to the amount of schooling that a person has gotten. So we're going to answer these questions now based on this data. So example 2A here, it says refer to the table of income data above. What variable is represented by the row headings, and what kind of variable is it? And what is the other variable in the table? So the first part of that question says, what variable is represented by the row headings? Well, it's referring to the highest level of education right here, that first column. So it's the highest level of education. And then it asks, well, what kind of variable is it? So it's referring to, is it categorical or numerical? Well, as we look at these answers for the highest level of education, those are not numbers, those are different categories, so it's going to be categorical. And the second part of the question says, what is the other variable in the table? Well, the other variable in the table, everything else is looking at their income level. Then it says, what kind of information is presented in the columns? And what columns correspond to each kind? So you can see that in the columns we have a couple of different things going on. We have, first we have the number of households. At each education level. The second thing that we have is we have the percent of households. So that's what these, so from here to here, all of that is dealing with the percent of households within each level. And the last thing that we have is this very last column way down here dealing with the median income. Let's look at the next part here. Interpret the table entry 31,153 in a sentence describing its context. So if we look at 31,153, that's looking at this number right here. Now it's important to look at that heading and see that these are referring to thousands. So really with that number we have to add 3 zeros after it. So the way that we can interpret that data is this represents not 31,153 households, but 31,153,000 households have a bachelor's degree or higher. Then it states, or then it asks, write a statement relating the median income to education of householder. So it says, write a statement relating median income to the education of the householder. So if we look at the median income, that's going to be these numbers down here, we can see that as the education level for the household increases, the median income level also increases. As we look at those numbers, we can see the numbers get larger and larger. So that's a statement that we can make based on their median income level. Then it asks how many times as likely was a family to have an income of at least $100,000 if the head of household had graduated college rather than not started high school. So how many times as likely was a family to have an income of at least $100,000 if the head of household had graduated college rather than not started high school? So as we look at this data, we can see here that when they have $100,000 and over and they graduated college, and versus not graduating from high school was 2.2%, so less than ninth grade. If we want to figure out how many times more likely they are to have a income of $100,000 or over, we would take and divide these two values. I'm going to take the 36.2 divided by the 2.2. If I take 36.2 and divide that by 2.2 to figure out how many times more likely it is for them to make $100,000 or more, when I do that, I get 16.5. And here it gets a little bit trickier. It says, how many times as likely was a family to have an income of less than $15,000 if the head of the household had some high school but no diploma, rather than graduated from high school? So when I look at this data, so we want to figure out, again, having less than $15,000, so I'm going to look at that column. In this case here, I'm looking at this data, because these are the numbers less than $15,000. And it's asking me that it has some, that to compare, going back down, it says some high school but no diploma rather than graduated from high school. So first, let's look at some high school but no diploma. That would be looking at these two numbers. And graduating from high school would be looking at these two numbers. So I'm first going to have to total those two. So if I add together the 17.3 and the 12.8, that's going to give me 30.1. So if I add together the 17.3% plus the 12.8%, that gives me 30.1%. And then the other two numbers were 8.8 and 7.8. So I'm going to add those together. When I do that, I get 16.6. And if I divide those two numbers together, we get approximately, we'll just round it here, you get approximately 2 times as likely. So you're 2 times more likely to make less than $15,000 if you have some high school but no diploma rather than actually graduating from high school. So those are some different points that we can make by looking at that data. Now let's end by looking at some different types of bar graphs here. It's important to make sure that you know how to draw a good bar graph and to know what a bar graph looks like. So let's look at this. It says bar graphs are appropriate when one variable is a categorical variable and the other variable is a numerical variable. A well-made bar graph has the following 4 pieces, and it's important to note that it's a well-made bar graph. You're going to be asked to make a bar graph on your quiz or on your test, and so you want to make sure that you include all of these pieces. Missing any of these pieces could result in losing points. So it's very important to have a descriptive title. You want to be able to look at that graph and know exactly what the graph is talking about. So having a title. So here I can see that my title is the median income level of households by level of education of head of household in the year 2005. So it's very descriptive. It identifies the variables being described. So the variables you can see are the axes. The householder education level is along the bottom axis, and on the side axis we see that it's referring to the income measured in thousands of dollars. The labels, so then we're going to label the scale, and they're going to be in equal intervals. So here we can see along the bottom that we have equal intervals. We have all these scales that are being labeled, and along the side they're in equal intervals here. They're not skipping, but it's Each of these lines are going by, counting by tens, which would really be counting by 10,000s, because remember we're adding 3 zeros after these. And the bars are going to be of equal widths. You wouldn't have one bar that's wider than another, so the bars have to be equal widths, and they're also not going to be touching. Okay, there's always got to be a gap between the bars for it to be a bar graph. It's going to be a different kind of graph if the bars are touching. So this is one type of bar graph. Now there's a more complicated type of bar graph. Remember all these data that we were looking at back here with all the protective gear? It'd be hard trying to draw just a single bar graph based on all this data. There's a lot of information here. So instead what we have is what's called a stacked bar graph. And this is a lot easier to read and interpret and be able to look at that data. But we can see here that looking at the beginner, that 32% of beginners wear 2 to 4 pieces of protective gear, 41% wear just 1 piece, and 27% wear no gear at all. So that's how we would be able to look at that. So breaks down that huge table that we had to a nice, easily able to read bar graph. And the way that we do that is each frequency was first converted to a percentage of skaters in that experience category. So for example, if we look back at the data, looking at the 27%, where did they get that from? Well, if we go all the way back here, and if we look at the fact that 188 beginners wore no gear out of a total of 709, well, 188 divided by 709, we got to be 27%. So 26.5%. They just rounded that to 27%. They did that for each of these other categories, and if you notice, they should all add up to be 100%. So they did that for the average skater and the advanced skater. And then each of the parts then are given different colors with a key to distinguish which one are which. So that's all important to be able to see what they did there. But like I said, having it written like this makes it real easy to be able to make and compare the data. We can see that between the average and advanced users, the amount of protective gear that they wore was pretty similar, where you can see that's a big difference, however, between those two categories and a beginner level as far as how much protective gear was worn. So there we have it. That is our first lesson. That is lesson 1.1. So hopefully now you have a better understanding of how we can compare some data here by looking at some variables and tables and graphs. And good luck now on your assignment.